Okay, the next video, I told you I would restart with my second example for call and call options. So we had call options for tier list. The strike price was 38. The price of the share is 39. By the way, if you didn't notice, this is completely irrelevant. That's the initial price of the share right at first when we buy the options. It has no impact at all on any of the answer. The only thing that matters is what the options value are and the price of the shares at maturity. This has no relevance. It has a little bit of relevance in how I chose my option premium. If the option premium was 50 cents here, it would make no sense to ever buy the shares. You could just buy the options for $38 for the option for 50 cents, and then you could exercise your option for $38. It would cost you $38.50 to get the option, so to get the shares. So you would never want to pay 39, and it would be what we call an arbitrage opportunity. But so the only thing this price changed is a little bit in how I decided to put the option premium here. But otherwise, this is irrelevant. Okay. Okay, so if at maturity the shares are valued at 37.83, what do? I do not exercise my option, right? I can buy it for 38 or I can buy it for 37.83. Well, I prefer to buy it at the lowest price, so I would not exercise my option and buy it at 37.83. My option expires worthless. My value of the option is 0. The profit on my option position is minus 1.32 right here. Okay. If the option is the underlying is worth 38.08 at expiration, right, or maturity, I would use my option because I can buy it for 38 and it's now worth 38.08. Remember, if the price of the underlying at maturity is below the strike price, I don't use my option. I don't exercise it. If the price is above, below, or equal, I don't exercise it. If the price is higher than the strike price, then I exercise it. So for these three here, we would exercise the options, right? But here, so I exercise. The value of the option is 8 cents. 38.08 minus 38. It gives me 8 cents. That's how much value I get out of my option. Unfortunately for me, I paid 1.32 for the option. So 8 cents minus 1.32 is my profit, which would be, aha, okay, there's something wrong here. On one of my slides I have 38.08. On the other one I have 39.08. Let's turn that to 38. I think I was tired of the profit being so low, so I decided to put it higher, but I forgot to change on one of my slides. This is the one you did, and the profit should be 1.24 negative, right? It's 8 cents value minus the price I paid for my option minus 1.32 should give you 1.24 negative, so that's a negative profit. Yeah, all my numbers here are different, so I will just change this number here to 39.78, and I'll just change this number, and this number is still 40.21. Okay, so if the underlying was 39.78, I would exercise my option. I would get 39.78 minus 38. I would get 1.78 in value. That would be the value of the option. Unfortunately, I paid the option 1.32 3 months ago, so 1.78 minus 1.32 would be my profit on my option, 46 cents if I calculated it correctly. Okay, the next example, the underlying is worth 40.21. 40.21 minus 38 gives me the value. That should be 2.21, I believe. The value of the option is 2.21 minus the price I paid for the option, 1.32. I don't know the answer to that one. Not 46 cents. Let's do it. 2.21 minus 1.32, 89 cents. Here we go. Okay. Hopefully that makes sense for everyone. This is how we find the value and profit of option. It's the second example we do. So hopefully it's clear. There will definitely be questions relating to that in your exam, right? So like 1 or 2. So you should make sure you know how to do these calculations, how to say if we should exercise or not exercise an option. So a summary of everything we've got. Again, I do recommend you just learn to do the logic. If you think about options logically, you'll get it right every time. Right? Ask yourself, this is an option that allows me to buy. Do I prefer to buy for 38 or do I prefer to buy for 36? Oh, I would want to buy for 36. I do not exercise my option. That's the safest way to do it. Okay, but I did write a little bit more formally here. Okay, if we have X as the strike price, C is the call premium. Okay, S little t is the value of the underlying at times T. S big T is the value of the underlying at maturity. Okay, the value of the option would always be 0 if the value of the underlying is below the strike price. This case here. Right? The strike price 38, the value of the underlying is 37.83. We don't exercise, the value is 0. Okay. In this case here, right, the underlying is 78, the strike price is 82. We let the option expire worthless. We don't make any money. The value is 0. On the other end, if the value of the underlying at maturity, this should be big T's here. No, actually it's small t because the value can be found at any time. It doesn't have to be just found at maturity, even though I did it at maturity in the previous case. In the case where the option is in the money, right? Basically, this is here saying that this is an option that is in the money, right? This part here says that's an option that's in the money. This part here says that this option is out of the money, right? If the option is in the money, the value of the underlying minus the strike price is the value you get out of your option. In order to find the profit, you just find the value minus the premium. So you just take this number minus C, take this number minus C, right? C is the call premium. Is that good for everyone? Okay. Let's do big bars at first. I'll do 2 graphs. I'll do the first one in blue, and I'll do, well, not 2 graph, but 2 function on the same graph, and the second one in green. Here on this x-axis, we will put the value of the underlying at maturity. We could put S little t, which would be the value of the underlying at any time, at any point in time, but I'll just put the maturity here. We could put little t, it would be the same, it wouldn't be any different. The value of the option, right, is at any given point in time, and it depends on the value of the underlying. Remember, ST is the value of the underlying, S capital T is the value of the underlying at maturity. And here we will put the value on your option. I'll call this V for now. Okay, the value of your option. I will do this graph in blue. Okay. Before doing that, there is somewhere in here we have something that is called the strike price. Let's say the strike price is here. This is X. This is our strike price. Okay. If we try to graph the value of the option as a function of ST, how does the value of the option change as the value of ST change? The idea here is pretty much what we did before in these 2 examples up here, right? The idea is if ST is smaller than X, let's look at that. If ST is smaller or equal to X, what is the value of the option? Oh yeah, it's 0, right? So I probably should have done the other smaller. I don't know. Let's try it small and see. So as long as ST, oh yeah, you see it, right? You can see that. As long as ST is smaller than X, the value of the option is 0. So all of these ST here, right? All of these ST, all of these value, ST would be smaller than X. smaller or equal to x. So the value of the option is 0. So I just made my line straight line here on that black line. It's 0. After that, when the value of st is bigger than x, the value of the option becomes st minus x. Now a lot of students struggle to see that, but basically it's just a slope, right? It's just a curve here with a slope of 1. And it goes up to infinity as st grow, and the slope here is 1. So that makes sense for everyone. This is the profile, right, of the value of an option as a function of the underlying. Good for everyone? Obviously the straight line here that I drew above, we could draw it below, but this straight line doesn't matter here because the value of the option is always the highest of 0 or whatever the value of the option. So all of these points here, you could get this negative value out of the option, but you could also just decide not to exercise your option and get 0, right? So we actually kind of ignore that part of the function here. Okay, this is just showing the value of the option as a function of the value of the underlying. Okay, now I'm just going to do the same graph. I'll redraw this whole graph because I can't erase parts of it, I think. Yeah, I'm not aware of any way I can clear just one thing. So I will erase all of this, stop the video recording, and redo this graph with just the blue line. And now we're going to draw the profit on the option visually so you can see it. Okay, we're back. I redrew in teal or in blue here the value of the option as a function of the underlying, right? This is ST again, but I can't write worth anything on a computer. Now what we want to do is we would like to draw the profit. Maybe I should put this in blue, right? It says the teal is the value of the option. Now what I want to do is I want to do the profit of the option. What does the profit profile on this option look like? When the option is out of the money, right? All of these points here on the blue line, right? This is all the option is out of the money. Its value is 0. When the value of an option is 0, what is the profit that you would make on it? If this is maturity and you sell the option, what profit would you make on it? You would make a profit that is exactly equal to minus the call premium, right? So let's say we say minus C. Remember, C is the call premium. Minus C is here. Basically, you would make a profit of minus C. Okay? All the way to the call premium. Not to the call premium, the strike price. Once you reach the strike price, what happens to the value of your option? The value of your option will go up, but you still need to pay C because you bought the option initially. It costs you C to purchase it, right? So it would be the same thing as this curve here, just shift down by C. So it would be just the same curve, but the vertical distance at any point, this distance here between these two curves at any point would be C, right? The green curve is C below the teal curve. Does that make sense for everyone? Can everyone understand a bit what I did here? By and large, a lot of students will not use this graph a lot. The one reason I show you the graph is that there is an interesting point here. What is this point here? How would you call this point? This is the break even point, right? This is the point where your profit is 0. Can you find the break even point for me? Okay, and I will write it here. It's going to be a little bit easier. Try to think about it. How do we find the break even? Well, first, we know that the break even will be when on the section on the section where the call option is valuable, where it is in the money, right? So we know that the break even point will be on the section where the option is in the money. Okay. Also, we know that the break-even point is where the profit, and usually because I'm an economist, I write profit as pi, where the profit is 0 on the option, right? We know that when an option is in the money, this is true here, right? So the value of the option is going to be ST minus X. But this is not the profit. This is the value of the option. We know that the profit is the value of the option minus the call premium. And we know that at the break-even price, this has to be true. Okay, by solving for ST, we can find for which ST we have break-even. So by doing solving for ST, I would get that X plus C is equals to ST. This is the break-even point, right? ST break-even. The value of the underlying for which my option position will break even is if the underlying is equal to the strike price plus the call premium. Let's go back here, right? And let's try to find the break even. Find the break even price of the underlying at maturity. We already know, by the way, it's going to be between 39.78 and 38.08, right? It has to be between these two. But let's find it. It's actually really easy if you remember what I just told you. If you don't, it's a little bit harder. You have to do a lot of harder maths. But here we know that it's X, the strike price, plus the call premium. So 39.32 should be our break-even price. Now just try to do it by yourself for a second. Try to convince yourself that it's the case, right? Stop the video if you need to. And now I'm going to demonstrate that it is. What is the value of the option? If the underlying is worth 39.32 at maturity, it's going to be 39.32 minus 38. It gives me a value of my option of 1.32. 1.32 minus the premium that I paid to get this option, 1.32 gives me 0. The profit on this position is $0. That's the break even, 39.32. Make sense for everyone? I don't know why I ask you questions. You can't reply. Okay. So we got the break even. You should be able to find the break-even. I don't ask you to do the graphs. I don't ask you to understand the graph that much. I find that the graph can help a lot. I don't know. The graph helps some student understand what's going on. Some student find the graph more confusing. Don't use the graph if you find it confusing. Use the graph if you don't find it confusing. I will do another graph like this. I recommend you use the graph for that one other example too, because it will help you. It might help you. It's not because you didn't find this one useful that you won't find the next one useful, right? So I recommend you watch them. It doesn't take me that long to do them, and hopefully for some of you it will be useful. Okay. Okay, that's pretty much everything I have to say. I don't know where I talk about speculative premium. I talk about it here, but I'll introduce it right now. The value of the option, okay, here in this graph, you might notice that I have two things, right? The black line here that I'm drawing on, and I'm not really doing a perfect job, but I'm just trying to follow that line. This black line is the value of the option, right? They call it in the book the intrinsic value of the option, but that line is the value of the option. The other line, the kind of brown line here, right, they're saying is the market value, right, or the premium on my option. Okay. The speculative premium, so basically this red line, this thing here, is the call premium, right? The difference between the call premium and the value of an option is called the speculative premium. So this vertical distance here between a point on the intrinsic value curve and the market value curve gives me the speculative premium. One thing you should notice is where is the speculative premium the biggest, right? It's the biggest closer to the strike price. In this case, the strike price is 24, right? The speculative premium, the distance between these two curves is bigger, right, around the strike price, and it is smaller, it gets smaller further away from the strike price. Why is that? Can you think about it right now? That would be a good theory question, right? Can you try to think about why that is the a fact? Okay, the answer is because the one of the big value of the option, suppose that the underlying, right, the underlying is currently priced at 24. The option is actually really valuable to you. Why? Because if the price goes down, you have downward protection. You won't lose more money than your option premium, right? So the option offers something really valuable to you. It's downside protection. If the price of the shares decrease past 24, you're going to lose a bit of money. You're going to lose your premium, but you can't lose any more money at some point because you have an option and you didn't actually buy the underlying, and it offers you a lot of protection. Does that make sense? And you retain your upside potential if instead of going down, if the price of the underlying was to go up, shoot up, well then you would get value out of your option. Does that make sense? So here there's a lot of value because it provides downside protection while keeping upside potential of the shares. Okay. However, when we're here, right? When we're here where I'm drawing, I don't know if you're seeing, but I'm trying to draw here. Right when on the left-hand side here, the value of the underlying is $4 and the strike price is 24. Do you think that in the next 3 months, the value of the shares of this company will go up to $24? It's highly unlikely. Okay, and because the price of the underlying right now is so far from the strike price, it's highly unlikely that you will ever get to profit from the upside of owning this option. So the speculative premium should be really small because you don't have a lot to gain from buying this option. On the other hand, suppose that we were on this hand here, this side, right, where the speculative premium is also pretty small. Would you find it really valuable to buy the option? Well, the option doesn't actually, in this case, doesn't actually give you a lot of downside protection, right? A share is valued at 70 bucks, $70 per share. Does it offer you protection? No, not until the share goes down to $24. So it's highly unlikely that you would actually use the downward protection offered by the option. So it loses some of its value when we're really far from the strike price on the right because you lose access to the downside protection. When we're really far on the left side, you lose access to the upside potential of the option. So the option, the speculative premium, is more valuable near the strike price. Does that make sense for everyone? Hopefully you can make this argument for me in an exam, but this is a question I could ask, right? Where is the speculative premium the highest? Why is it the highest at that spot? So that's it's pretty important you understand this. Okay, just again ask me question during office hours if you need some help on this. I will do, no, I won't do put options in this video. I will do put options and hopefully convertible bonds in the next video. So thank you for watching.